Here are your examples for 7-3. 7-3 is about similarity and transformations. In other words, we're going to use transformations in order to show similarity between two figures. First of all, we're going to take a look at identifying similarity. Two figures are similar if the second can be obtained from the first by a sequence of transformations. That's the same thing we have been doing, but now we're also adding dilations. And remember, dilations introduce the concept of differing size. In other words, they're going to be the same shape, just like congruence, but now we're going to have different size, so they're no longer congruent, they are similar. So that's the difference between similarity and congruence. Congruence, same size, same shape. Similarity, same shape, but a different size. But it has to be a proportional size, which we'll see in a minute. So let's take a look at example number 1. In example number 1, they ask us to determine if the two triangles are similar and do so by using transformations. Since the orientation of the figure is the same, one of the transformations is translation. So all we're going to do is we're going to slide it down in this direction until letter D is exactly over letter G. And that's what they say right here. We're going to move it 2 units down and 5 units to the right and map D over G. Notice that you can't map D over G at the same time that you always also map E over H or F over I, because they're simply not the same size. In other words, when we if we move this triangle over here, it would fit through about like there. I didn't do that perfectly accurately because I want you to see some measurements here in a minute. So let's clear this out a little bit. So now let's take a look at this. The first thing I want to do is I want you to notice that we can count these up, and we have a side here of 4. This side here is 3. This side here, if we count them up, we've got 2, 4, 6. And this side, if we count them up, we have 2, 4, 6, 8. We have 8. So you should recognize that on this triangle here, if this is a 3 and this is a 4, and we of course have a right angle here, this has to be 5. But you should also notice that this is a form of a 3, 4, 5 right triangle. We could also remember use the Pythagorean theorem if we're looking for the hypotenuse. Hypotenuse equals the square root of leg squared plus leg squared. You should have this on your gold sheet. You're going to use this again for this chapter. We're always looking for hypotenuse. But in this case, we can do it as a form of the 3, 4 right triangle. This is 2 times 3, this is 2 times 4, this would be 2 times 5, so that makes that side 10. So there's our 6 sides of our 2 triangles. What we need to do then in order to determine whether or not these figures are similar is look at the ratios. So notice that you have HG and ED, and that's 8 over 4. That's these two numbers here, 8 over 4. Then we have GI and DF. That's 6 over 3. Notice since we went from the larger triangle to the smaller triangle on the first one, we're going to do the same thing on the second one. So it's always going to be the larger number on top. And then lastly, we can look at 10 over 5 as our last one. But notice, and this is one of the things you're going to have to realize, you're going to have to be able to see when you have equivalent fractions. And it's looking like a fraction. In this case, you could just divide. 8 divided by 4, of course, is 2. 6 divided by 3 is 2. And 10 divided by 5 is 2. But also, if we looked at this in the opposite way, we could look at it this way. Let me show you what I mean. Instead of saying that it was 8 over 4, we could have said that it was 4 over 8 for our first. And we could have then said 3 over 6 for our next. And then we could have gone with 5 over 10, and you should see that these are all equivalent to 1/2. So in other words, it depends on if you look at this figure as, it didn't really tell us here which was the image and which was the pre-image. If the large triangle was the pre-image, then we would have a scale factor of 1/2. If the small triangle was the pre-image, then we would have a scale factor of 2. It didn't tell us which was which. But remember, in every case, all you're going to do is you're going to compare corresponding sides of the two figures in order to check for similarity. If you do not have a constant ratio comparing the sides to corresponding side to corresponding side, then you do not have similar figures. The next example, I believe, will help you see that really clearly. Okay, in sample number 2, we are asked to determine if the two rectangles are similar by using transformations. So we'll take a look at this, and you can see that clearly the orientation is different. In this particular, the smaller one, we're looking at it's wider than it is tall, and in the larger rectangle, it's taller than it is wide. So one of the things we want to do is rotate on 90 degrees, and we're going to do it around the point W. Now you can see why in that earlier lesson we did some rotations around a particular point, and you can see that if you rotated this figure up in this direction, it would end up looking like this right here. So now we have two figures side by side, and we can compare corresponding sides. These two sides correspond. These two sides correspond, this length here and this length here, etc. So again, one of the things that we need to do is take a look at things here and recognize that this length right here is 3. This one here is 1, 2, 3, 4. This is 5. Up here we have a side length of 4, and here we have 7. So we have side lengths of 4 and 7 on this rectangle and 3 and 5 on this rectangle. So we're going to compare corresponding sides. Well, the corresponding side here, the 3 here corresponds to this 4 here, or this 3 here corresponds to this 4 here. In either case, we have 3 over 4, comparing both of those. And then when we have these sides here, we can compare this 5 to this 7, or we can compare the other 5 here to this 7. And in either case, we have 5 over 7. And now we're going to take a look at that, and you should recognize that 5 over 7, or 5/7, is not equal to 3/4. And the way you could check that is to put it right in a calculator, divide 5 divided by 7, write down your decimal. Remember, that's how you do that. Put in a calculator 3 divided by 5, and you would write down that that is 0.75. And you can recognize that those two are not equal to each other. Another way to do that is you could get a common denominator and go through it that way, but I think the quickest way is to check it in a calculator. And because these ratios are not equal, these are not similar. These are not similar triangles. I'm sorry, similar rectangles. Please press pause and do letters A and B. Remember that when you answer these questions, you're going to be doing several things. First of all, you should answer yes or no. Secondly, you should answer what transformations you need to do. And lastly, you should tell what the scale factor is if they're similar. If they're not similar, you should say something like 7 over 3 is not equal to 8 over 4, for example. Or you should just say that the scale factor was a scale factor of 3. Make sure you give all 3 answers to these problems. Here's a quick little review here. Don't forget to use the scale factor, what you know about scale factors. Similar figures have the same shape but may have different sizes. The sizes of the two figures are related to the scale factor of the dilation. If the scale factor of the dilation is between 0 and 1, you're going to have a dilated figure that's smaller than the original. I'm not going to spend much time talking about this because that wouldn't be really similar, although they would technically be similar. A better answer to that would be that they're congruent for whenever you have a scale factor of 1. And of course, if the scale factor is greater than 1, then the dilated figure will be larger than the original. Let's take a look at problem number 3. Ken enlarges the photo shown by a scale factor of 2 for his web page. So he's going to enlarge this photo right here for his web page. He then enlarges that web page photo by a scale factor of 1.5. So the first scale factor is 2, the second scale factor is 1.5. The original, so let's write it right on here, was 2 inches. Well, that obviously would be this side by 3 inches. So it's 2 by 3. So I'm going to do this a little bit differently than they do it down here, and I'll show you a way that you might want to do it yourself. So I would write that we have a 2 by 3. We have a 2 by 3 figure. And then I'm going to have a scale factor of 2. So remember, what do we do with a scale factor of 2? We multiply everything by 2. So I'm going to multiply everything by 2. and then I'm going to get answers down here of the new dimensions, but then after I do that, I'm going to also multiply it by 1.5. So I'll put that down here right now. I'm going to multiply by 1.5. So if I go 2 times 2, I get 4. 3 times 2 is 6. So now I have a 4 by 6, and now I can do the same multiplication. I can multiply 4 times 1 1/2. Well, 4 times 1 is 4, plus half of 4 is 2 more, so that's 6. So I'm going to have a 6 by 6 times 1 is 6, and half of 6 is 3. So 6 plus 3 is 9, so I'm going to end up with a 6 by 9. Notice all I did is take my dimensions here, and I multiplied them by 2, and then I multiplied them by 1.5. Some of you will remember, or some of you will think of the fact that 2 times 1 1/2 is 3. If you go 2 times 1.5, that's 3. So what some of you will do is you'll say that you'll multiply your two scale factors together and then just say, you know what, I'm just going to multiply 2 times 3, and I'm going to multiply 3 times 3, and I get 2 times 3 is 6, and 3 times 3 is 9. There's multiple different ways to do this. You can also take a look at the exact way that they did it here. Always will come out to the same thing. Because it's multiplication, you can do it in any order you want because it's commutative. The printed photo will be 6 by 9 inches. All three photos. Another thing they asked you, are the enlarged photos similar to the original? And your answer would be yes, of course they're similar because we used a dilation. Please press pause and do letter C.